Graphs of exponential function. Here we will discuss two exponential function. First question is plot the graph of the exponential function y equal to a to the power x, a greater than 1, which is also called exponential growth. And we will also discuss the graph of the exponential function y equal to a to the power x when a is less than 1. That is called exponential decay. What is important in exponential function? The exponential function y equal to a to the power x, here a is greater than 0. Okay, a is greater than 0. You should remember it. A is greater than 0 is called an exponential function. The function y equal to a to the power x when a is greater than 0 is called the exponential function. And the graphs of the exponential function are non-linear or not straight line. It is a short question. Question will come whether the graph of exponential function is straight line or not straight line, linear or not linear. So you should remember graphs of exponential function are non-linear or not straight line. So first we will discuss the plot of the graph of exponential function y is equal to a to the power x for a is greater than 1, which is called exponential growth. This is the graph of y is equal to a to the power x, a is greater than 1. How we will plot this graph? You see, when x is equal to 0, then what will be the value of y? Y will be equal to a to the power 0, which will be equal to 1. So here you see, when x equal to 0, y is equal to 1. This coordinate is 0, 1. Then what will be the nature of the y equal to a to the power x? If you increase the value of x. If you increase the value of x, then the value of y will increase monotonically like this. Okay. So when x is positive and increases, the x value increases and it is positive, the value of y increases monotonically. But when x is negative, you see, when x is negative, then what will be the value of y? Y will be equal to a to the power minus x, and a to the power minus x means 1 divided by a to the power x. So when y equal to 1 divided by a to the power x, if you increase the value of x, then there will be decrease. There will be decrease in the value of y like this. So this will be the nature of a to the power x when a is greater than 1. Then we will discuss or plot the graph of the exponential function y equal to a to the power x for a is less than 1. So in examination you will find questions to plot the graph of exponential function y equal to a to the power x for a value lies between 0 and 1. Remember, the function y equal to a to the power x, I have told you, here a is greater than 0. A is always greater than 0. So sometime question will come, a is less than 1, not a lies between 0 and 1, and which is called exponential decay. And this will be the nature of the graph for a is less than 1 or a lies between 0 and 1. Okay, y equal to a to the power x, so x equal to 0 means y will be equal to a to the power 0, which will be equal to 1, so you will get this point. Here x value is equal to 0 and y value is equal to 1, so the coordinate is 0 and 1. And you see, when the value of the x increases, what will be the nature of the curve, and when it decreases, what will be the nature of the curve? Since the value of a lies between 0 and 1, so the value of a will be a fraction, and fraction to the power, if you increase the value of x, then this will be the nature of the graph, and this is also called exponential decay. In most of the problems in physics or in most of the experiment, you will you need this type of graph, that is exponential growth or exponential decay, like your radioactive decay. So this formula or graphs of exponential function will be very much useful in physics. Thank you.